This is the seventh theory session of the problem-solving test course. We will continue to talk about compound growth estimation techniques. This time, we will focus on the rule of 72. And also, we will focus on the rule of 42, 96, 114, 132, and other rules. We will learn how to derive those rules, as well as how to apply them to McKinsey problem-solving test questions. Let us start with the following example. As always, you might want to pause the video now and try to solve the question on your own, and then check. Which of the following would be the minimum required annual growth in the revenue of shadowing that would see it represent more than half of ABZ Industries' revenue in 10 years? And the text tells us that the revenue of ABZ Industries is $11.64 billion, and the revenue of Shadow Inc., its subsidiary, is $2.83 billion. And the growth of ABZ Industries is 5% per annum. So here's our problem. And we have two ways of solving it. This straightforward way and the roundabout. First of all, we would find the revenue of ABZ, perhaps using the contribution margin. Then we would calculate the revenue of Shadow as the half of the revenue of ABZ. Then we would need to calculate the growth rate of Shadow that would help it reach the desired revenue. But the problem is that in this case, beside the long computations, we would also need to compute this guy here, which might be a nightmare in a PST. So I wouldn't really advise you to take this approach. But here's another way of tackling the question. It's called Rule of 72. We know that the revenue of Shadow now is about 25% of the revenue of ABZ, right? And we know that this share has to double to 50%. So it has to double in 10 years. That means that we can use the rule of 72, which tells us that x minus 5 times 10 equals 72, or that x equals 12.2. And our answer is B. Well, I guess at this point it sounds a bit like magic, but I will explain everything in a moment. Here's what the rule of 72 says. If some quantity grows by x% for n periods and doubles, then xn approximately equals 72, provided that x is not greater than 20. Here are a few examples how we can use it. In all the cases, we notice that a number almost doubles or doubles when grows at a certain percent for n years. That means that the percent times n equals approximately 72, and we can easily find n, the number of years. For some math nerds, and most consultants are math nerds anyways, here's a proof of this result. This proof suggests that the rule of 72 is not the only one of its kind. And indeed, there are similar rules as well. For example, the rule of 42, the rule of 72, the rule of 96, 114, 132, 144, 156, 168, and so on. And here's how you can build similar rules on your own. For example, start with the rule of 42, multiplication by 1.5. Combine it with the rule of 72, multiplication by 2. In combining, we sum up the anchor numbers, which is 42 and 72, and take a product of the multipliers, 2 and 1.5. And we arrive at the rule of 114, multiplication by 3. We got 3 from multiplying 2 by 1.5 and 114 from summing up 42 and 72. Here's another example. Take the rule of 132, add the rule of 72, combine, and get the rule of 204, multiplying by 7. Well, now it's high time we tested this knowledge in action, right? Again, pause the video and try to tackle the question on your own, and then check yourself. The cost of attending Harvard College is $75,000 per year and is growing at 6.6% per annum. A typical undergraduate degree at Harvard comprises 4 years of education. If this trend continues, what is the minimum number of years which need to pass before the cost of a Harvard undergraduate degree climbs over $400,000? So if 1 year of college education right now costs $75,000, then 4 years cost $300,000. And the math question that we face is the following. $300,000 times 1 plus 6.6% to the power n, where n is unknown, equals 400k. Let us simplify it a bit. And we see that this is a great opportunity for the rule of 4/3. Let's make it up. The rule of multiplication by 4, the anchor number is 144. Rule of multiplication by 3, the anchor number is 114. And then our anchor number here is the difference of these numbers and is number 30. So our newly derived rule of 30 tells us that 6.6n should roughly equal 30 and that n is about 4.5. And then our answer is C. There is one more similar rule we need to learn, the rule of 72 for shares. Start with the rule for absolute values and derive at a similar one for shares. In simple words, if we want to grow the share of a certain object in its base, we must subtract the growth of the base from its growth and apply the rule of 72 as always. The intuition is simple. If we are running at 6 miles per hour and the dog is running behind us at 10 miles per hour, the dog is catching up with us at 10 minus 6 equals 4 miles per hour. And again, for those interested, here is a proof of this result. Here's another example, this time from an official practice test. Pause the video and try to solve it. If the total innovation capital in Exhibit 1 were to grow at 5% per year in the future, which of the following would be the minimum required annual growth in human capital that would see it represent more than half of the total innovation capital in 10 years? So from reading the text, we learned what human capital is and learned that we'll need to sum up three numbers: 1.1, 0.7 and 1.5. So total human capital right now is 3.3. So we know that right now human capital is about 25% of total innovation capital. And this number needs to double in 10 years. Therefore, by a rule of 72 for shares, we know that x minus 5 times 10 roughly equals 72. Hence, x minus 5 roughly equals 7.2 and x is about 12.2. And here our answer is B. Let us synthesize what we have learned today. The rule of 72 says, if some quantity grows by x% for n periods and doubles, then xn approximately equals 72, provided that x is not greater than 20. There are all kinds of similar rules. Rule of 42, 96, 114, 132, and so on. The way you derive them is by summing the anchor numbers and by taking a product of the multipliers. A similar rule for shares says, if we want to grow the share of a certain object in its base, we must subtract the growth of the base from its growth and apply the rule of 72 as always. That's it for now. Any questions or comments? Please leave them below the video and I'll be happy to reply. Thanks for watching the video and until next time.